Hello, everyone. This is the math call. So we're gonna start with the topic of the real numbers. This topic, I believe everyone used to learn in previous years. But today, I just want to review a little bit for make sure everyone still recall about this topic before we go to the next lessons. So what are the real numbers? Most of time when you in the primary level grade 7, you will answer says every number on the number line, right? So but today we're gonna break it more in detail, okay, in details for the real numbers. So the real numbers will be break it down to be two kinds, two parts. Okay, first is a rational, and second is a irrational. Okay, so I can write down here the real numbers, break it down to be rational, rational number, and the irrational number. So write down here, rational and irrational. Okay, so what is the rational numbers? Okay, but before that, we're gonna see a subset of rational is the integer numbers. So integer is a subset of rational. So maybe I write down here, integers number. Okay, rational number. A rational number is any number that can be expressed as a ratio or quotient of two integers. Okay, the set of rational number is includes both the positive and negative fractions. Okay, so we cannot relate rational number as easily as the release number in the other set, but we do this one. Rational number is any number that can be expressed as a ratio. So this one, rational, will the as a ratio, that means we have, for example, A over B, such that A and B are integers. Are integers number. Okay, which is have restriction, which is B, this B, okay, is not equal to 0. Because if equal to 0 become undefined, correct, everyone? These are fractions, right? Or sometimes we call ratio. So A over B. A and B are integers. Okay. A and B are integers. And B shouldn't be 0. So I leave right here. And B shouldn't be 0. So integers numbers. Since the integer numbers is a step of rational numbers. Okay. So integer number have how many kind? 3 kind, right? Is integer number have 3 kind. The is a rational number, the whole number, and another one is 0. So if I wrote it down in this way, okay, I like this one. So integer number have 3 kinds. Okay, first one is 0, and positive integer 1, 2, 3. Okay, and then and so on. We use a 3 dot represent up to positive integer infinity. And on the left hand side, it's gonna be -1, -2, and -3, and so on to negative infinity. So that integer numbers have three kinds: zero, neither positive nor negative. Okay, so then the positive integer means 1, 2, 3, 4, 5, 6, and so on to infinities. And for the negative integer, that means -1, -2, -3, and -4, -5, and so on to negative infinity. Okay, so we can see if decimal or fraction, it doesn't include. Okay, is like a fraction. If you like fraction or decimal, this are not integer number. Okay, so then within within the integer number, we gonna have three kinds. That what I'm saying. Okay, so zero. Okay, but if we start from this one, if I write down from draw this one from zero, I mean from 1. Okay, so if I draw this one, so if start from 1, 2, 3, 4, 5, 6, and so on to positive infinity, this one we call natural number or counting number. Or counting number. Sometimes we call counting number. Okay. And then for if we, so we can, now we know the natural numbers or counting number is a subset of integers, and integer also subset of rational numbers, and rational numbers are set of real number. Okay, so if start from zero, it start from zero. I'm trying to make in the table. Okay, so easy to remember or keep in mind for each definitions. So if start from 0, 1, 2, 3, 4, 5, and so on to plus infinity, we call this is the whole numbers. Okay. So then from this, if I draw up to here, cover up like this, okay, and down to here. Okay, so for if I load this one, make the chart maybe easier, right? So we know integer numbers, the integer numbers, okay, mean three kinds, right? Start from 0 and the positive integer, negative integers. If positive integers, we name it rational number or counting number. If start from 0, 1, 2, 3, 4, 5, and so on to plus infinity, we call the whole numbers. So whole numbers start from 0. Okay, so we can say natural number is a subset of whole number, and the whole numbers is a subset of the integer numbers. Okay, and then at this stage we we know now integer number is a subset of rational number. Okay, so if I write it down by use this one, draw the put in the box. Okay. Oh, sorry, it doesn't want me to draw. Okay, so I want to make in the in the chart of in the figure. Okay, so we have this one now. This box is a rational number. Okay. So from this real number, we can break it down in this way. This is a real number have two kind rational, right? This box, the blue color here on in the box here, that means rational number. And then from this one, I can draw another, the other side, this one is an irrational number. I try to use different color, okay? So this one is an irrational number. Okay, so now I draw in the box. Okay, so now everyone kind of understand now what the meaning. So one more time, real number have two kind, rational, irrational. Okay, so this box, this side here is the rational numbers, and this side is the irrational numbers. Okay, so rational numbers mean any number we can just say is any number that we can express it as a ratio or quotients. Okay, like a over B. So see, example for A or B, right? For example, I use the green color. For example here, for example, for rational number, like a 1/2, or maybe 3, -3/5, okay? And that's when this one rational number can load it down as how to say, how to write it down in this one in the fraction. So if I load only two is a rational or not? Yes, because 2 can write down as a 2/1, right? So this is still is a rational number because we can still can write down in the ratio pattern. So how about 0? Also yes, because 0 can be over 2/3/1, even over negative, because this one still equal to 0, correct? So this is a rational. Or you can write it in any like a maybe 25/4, something like this, still count to be rational number. Okay, but then one more thing, this is really important for rational numbers. Rational numbers, there are two kind of decimal within rational numbers. is repeating decimal and terminating decimal. So this one break it down. 2 kind. Repeating decimal. And this one is terminating decimal. Maybe a different color. Terminating decimal. Sorry, I have to, not enough space, so I have to write very small. So now what the meaning of repeating decimal? For example, I have 1/3. 1/3 is still in the ratio of fraction form, like A/B, right? But then this one, this convert to decimal. This one gonna be 0.333, correct? We can write down a dot, or we can write it down 0.3 and put the bar on the top. Okay, so this called repeating decimal because they keep repeating 0.33333 infinite. But for terminating this decimal, for example, we have like what number we can use? Maybe 1/8. Okay, this is a fraction or ratio, correct? 1/8 is like A/B. But then we convert to decimals, we're gonna have 0.125 or 2/5 like this. This is a terminating decimal equal to 0.4. Okay, terminating decimal means when you do the long division. For example, 2/5, right? 2/5, we're gonna have 2 divided by 5, correct? So 2 cannot divide, so like 0 and like dot follow 0, so become 5, 4, 20. So you can see remainder is a 0. So if remainder 0, so we call terminating decimals. Okay. So if we keep repeating the decimal, that is, for example, in the orange one here, we call repeating decimal. Okay. So then these are rational numbers mean on the left hand side. Okay. So now we go for right hand side, irrational number. Okay. Irrational number is what is that? It's those real numbers that are not rational number. Okay, that means irrational numbers couldn't lie in the fraction form or ratio. Okay, so for example, this one for example here, most of time gonna be in the square root thing, square root 2, square root 3 like this. Okay, so how about square root? And most like a prime number, but some number is composite number also rational, like a square root 6, okay, or pi, okay. So all this one irrational because square root 2, if you use calculators, square root 2 is what? Equal to 1.414 and still continue, right? To 13562 something. Okay, and the numbers keep going without repeating. So in this case, you see this is irrational. Okay, like a pi, right? Pi we know is what, but in general, this one we like approximate, this approximate size equal. Okay, the approximate size. So in general, square root 2, like a square root 2, come back here. We use only one about, right? About the number we use to calculation 1.414. Okay. but actually they can continue. So this one, so like a pi, same thing is a 3.14, right? 3.14159 something, okay, and keep going to 654 like this, and the number keep going without repeating. So in this case we call irrational numbers. It's different from this one, right? This one we call repeating, because they keep repeating after decimal the same number, but this one after decimal they keep have the different number, continue, okay, infinite. If you have calculator you can test with this one, okay. So if, for example, in this case, if I write it down only say 3.14, if I write only this one should be rational, irrational. If question like this one, so this number represent rational number, okay. But if they like pi, then equal to this. If like pi, then represent irrational number, because they will keep going to infinite number digits for the decimal places. So at the same time, normally we know like a 3.14. This one, if we write in the fraction form, correct, gonna be 22/7, right? So if you like this one alone, right? So this one count to be rational also, because we write in this form, and then we're gonna write the number on only 3.14. So this is gonna be rational number. But if you like in the pi, so it's gonna be irrational numbers. Okay. So what the pi? This one come from the circumference. Okay. What the pi? How you get the pi? So we know circumference is what, 2 pi r, right? It's a ratio. It's a ratio. How to say? It's the number. It's a ratio of circumference and diameter. Okay, so the circumference is 2 pi r, right? The ratio, right, is a ratio. So over to, the ratio to the diameter. Diameter is what? This r, okay, not 2, sorry. 2 pi r, okay, this is a circumference formula, right? The ratio is a ratio of, it's a ratio to the diameter. Diameter is what? 2r. Okay, so 2r cut, so you get pi. So that's the pi come from the ratio of the circumference and diameter. Okay, so then this one, most of you learned already last year, and now this class, which I just want to review, okay? Okay, so this is about the idea of the real numbers. Okay, one more time. Real numbers, break it down two kinds. One, rational. Second, irrational. Okay, so you can write the flow chart. This one is a rational, and come here is irrational. So rational is the number which we can write in the fraction form or ratio form, like a over b. A and b are integers number, which b shouldn't be 0. An example behind here. So rational number have two kinds of decimals, repeating decimal and terminating decimal. The example here, okay. And within rational, they have that there is an integer number. Okay, there is an integer number. So integer number have three kinds. Okay, 0 and positive integer. Which is positive integer we call rational number or counting number. Okay, natural number, counting number, the same meaning. Okay, but you can remember very easy, right? Counting number, you count the number. You can count it. Okay, like for example, in the class, I ask you how many students in your class, right? So you're gonna start to count from what? From number 1, correct? Okay, the number of students. So 1, 2, 3, you keep counting. So that's why we start from here, number 1 here. So this is a natural numbers or counting numbers. and then it starts from the 0, 1, 2, 3 to plus infinity. We call whole numbers. Okay, whole number. They have O here, O like a 0, so whole numbers. Okay, and the left hand side is a negative integer. That means start from -2, -3, -4, and so on to negative infinities. Okay, so that's the meaning of the real numbers. Okay, so far is about this. Oh, one more thing, palm number, right? Palm number like a square root 2, like a what a palm number. Most of number is, and with the square root is a irrational. So like what a palm number. Palm number, we gonna have a palm number, right? Palm numbers start from what numbers? 2. Palm number is the palm number is the number itself and 1, right? The factor. Palm number, right? And there is the 2 positive factors, itself and 1. For example, like a 2, 3, 5, 7, 11, like this. So like a 2, the factor of 2, the positive, right? Have to be positive number. So 2, the factor of 2 is what? 2 times 1. That's all can be. And 3 also should be 3 times 1. Okay. So how about if number 6? 6 is not palm number. 6 is a composite number because 6 can factor by 2 times 3, 6 times 1. So this one is called composite number. Okay. So this most of palm number gonna be irrational with the, like in the square root, the search form like this is the irrational number. How about if I give you, say, square root 25, what this number? Is an irrational number, rational number, or whole numbers, or integer numbers? Okay, 25, you can see. 25 is, if you take the square root, right? If you take square root, gonna be equal to 5, correct? So square root 25 is not irrational number, okay? Because we can take square root become 5. So 5 can be what? 5 can be rational number because 5 can write it down 5 over 1. Okay, and also 5 can be integer number also. Here, integer like here 4, 5 can be positive integer, which is another name is what? Natural numbers or counting number. Okay, and rational number integer, yeah, can be integer, and also 5 here can be whole number also. Okay, because 5 drop in integer numbers and the whole number. So in this case, when the answer, you can answer, say, square root 25 can be rationals, can be integers. No, cannot say integer because it's positive. Can be a counting number or natural numbers, or whole number. Can be 3 kinds. Okay, everyone get about the idea? Okay, so I think that's the meaning of real number. So I'm gonna go next one for example. Okay, example now. Determine whether each statement is true or false. First one, every rational number is an integer number, true or false? True or false? Rational number is an integer number. False, right? Because rational number, every rational is they say every rational is an integer number. No. Okay, because for example, like a decimal is not integer, so this one for wrong. Okay, so B, every counting number is an integer number. Every counting number is an integer. Yes, right? Okay, this one correct too. Every irrational number is a real number. Yes. Okay, so if you still remember the flow chart I get we write in the box. Okay, you can review and one more time this one. Okay, so now we go next example. Okay, now next example. List the numbers, describe it and graph the numbers on the number line. See question A. The whole numbers less than 4. Okay, so then we will number question A. Then we draw the number line first. Okay, draw the number line. I want to use the same color. So draw the number line. And then I want every time must light the arrow side of the both end sizes. So whole numbers less than 4. Everyone still remember whole numbers is? Whole numbers start from 0, right? 0, 1, 2, 3, 4, and so on to positive infinity. Whole numbers less than 4. Maybe I can start 0 right here. 1, 2, 3, 4. Okay, less than 4, whole number less than 4, whole numbers less than 4. So 4 doesn't include, so we like open dot. And this one back dot. Less than, okay, so we call less number. So whole number will end with a 0. So that include. After that, you write the state notation. So write it down as 0, 1, 3, 4 doesn't include, so we don't write down, don't need to write down. So that is the notation, the set of notation. Okay, so 0 to 3, 4. 4 doesn't include. Okay, this is question A. Now for question B. B, draw number line again. Again, draw the arrowhead both sides. So the integers between 3 and 9, between, right? Between 3 and 9, between, so 3 and 9 doesn't include. So, so maybe I can say 0 right here. Okay, 1, 2, 3. So I start from 3 here. 4, 5, 6, 7, 8, and 9. So 3 and 9 doesn't include, right? So from 3 we like open dot. Then 4, because integer, okay, we have to represent with a dot side. So 4 include back dot, 5 back dot, 6 back dot, 7, 8, but 9 doesn't include, so we like open dot. Okay, this is a graph represent on the number line. Now like the solution set. So we like that become 4, 5, 6, 7, and 8. Okay, so that's a represent for question B. Now go C. Go C. We draw this one. Question C. Okay, the integer greater than 3. Okay, draw a number line also. Again, draw the number line. And then line both sides with the arrow side, both sizes with the arrow side. integers greater than -3. So -3, maybe I can write down here. -3, -2, -1, 0, 1, 2, 3, and because greater than, so we just stop right there, and then greater than integers greater than -3, greater than not equal, right? So -3, we just like open side, open dot. Greater than, so -2 include, -1 include, so back dot. 0 include 1, and so on to infinity. So after that, represent the underline here with the back 3 dot. That represent and so on. Okay, so up, go on up to infinity side positive, and actually this side is a negative. Okay, so then this a graph represent on the number line for question C. But then we like the solution set. So gonna be negative, because 3 doesn't include, greater than -3, 3 doesn't include, so this is going to be -2, -1, 0, 1, 2, 3, and then like dot, 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 represent. So the greater than, it is just greater than -3. Okay. So now go last question, D. Question D. Okay, again, like the number line. Okay, so then like the arrowhead for both sizes. Then the real numbers at least, the real number at least 6 and at most 18. At least 6 on the number line, usually number line we represent with the x of x, right? X available. So in this case, at most, that means maximum. Maximum, we like x. Maximum, that means can be equal to 18 maximum, and the less, okay, at most. So maximum is 18. And this one gonna be at least, so that means can be greater than 6, right? Okay, then this one we leave x less than or equal 18 and greater than 6 or equal, greater than or equal to 6. Okay, so that's the notation side for question D. Now how to plot graph? 6, right? So maybe I can start here 0, 1, 2, and whatever up here. And I start here, say 6 and 7, 8, 9, and then you can write dot here to up to here become 18. Okay, so now because the including, I have the equal sign underneath here, this is include 8, 6 and 18, so this is a back dot, and 18 include back dot. And because this is a real numbers, so we represent with one line from 6 to 8. We use one line because of the value between, for example, like a 6 to 7, they're gonna have decimal point or fraction, right? Like a 6.60.1, 60.05, something, right? Or like in the fraction form, that's include. So we will use the number with the line represent. Okay, and then this is 18, this is 6 include. Okay, so then this one, and the notation side for this question D is this one. So you can write down x less than or equal 18 and greater than or equal to 6. That's the notation side. Okay, but in the question A, B, C, they're different from question D, right? Because it's a whole number, this integer numbers. So they have to represent with a dot, with a dot. Cannot draw one line. It line that include everything, decimal, fraction, even square root, search form. Okay, that's the real numbers. Still remember the definition we just finished in the one I wrote in the box. Represent real numbers have two kinds, rational and irrationals. That one. Okay. I think that's all for the real numbers. Okay. So I will leave it right here, and then you can check in Google Classroom. I will give you handout also, and you can review one more time and watch this video one more time also, and do the question. I will write in detail what question you have to do. Okay, so I think that's all for today. See you next class. Bye bye.